Welcome back with another video on TryHackMe.com. This is Zahir Nazir and we are doing CICD and build security following DevSecOps on TryHackMe.com. I already started the attack box machine and I already started the machine that we will be working on. And today we will take care of the task 8 here. If you are following along, please make sure to subscribe, click on the subscribe button, and if you have any comments, please put it in the comments below. And we will continue with the task 8 here. So before we delve into the task 8, I want to show you that I already have power on the attack box. And before I do anything, we need to make sure that we are basically having the same IP addresses here or not. As you can see, some of the IP addresses are the same, the other ones are not. As you can see, the GitLab is 10.246.150, and now Jenkins IP address is changed. It's 10.203.160, and J agent is also 10.23.171. The rest of the range is still the same. So what I'm gonna do is I'm gonna write it down on my notebook here just to make sure that we are on the same side. And if I need to change any IP address in one of my scripts, I will be able to do it. All right, so this is one, and then we have 201 for G runner 1, 202 for G runner 2, and 203 for G runner 3. And for Jenkins, of course, it is 10.203.160, and for J agent it is 10.200.3.171. okay, so let's change our command which we need to run at the start of the room, because we came back after 1 day, so everything is, we started from scratch. Okay, I'm gonna paste here. Okay, we are good to go. Let me check if everything is working fine, especially the GitLab.loc copy. It is opening. Yeah, it opens. I'll just create a new tab here, paste, but I need to put HTTP, otherwise it will go to Google for searching, which I don't want to do. All right, so it is working fine. So let's continue with our theory for now. Okay, we are good. Task 8, securing and build pipeline. With our build server secure, we will take a look at the pipeline itself next. Even if we do everything correctly, we still have to consider that one of our developers may be compromised. That means in-house attack. Somebody came to your company pretending to be a developer. He may be a developer, of course. Usually hackers are a developer, basically. They have bad development background. But he is insider, and he's trying to take down your company. So we are considering that, okay, one of the developer is compromised already, or somebody is blackmailing your original developers. Whether the actual developer is compromised through a social engineering attack or simply their credential being exposed, this compromise could be downfall of our pipeline and build. Fortunately, there are protections that can be applied. Yeah, very true. Let's see what protections we have. Access gates. Access gates, also known as gates or checkpoints, serve as stages within a software development pipeline. They ensure that code progresses through pipeline only after meeting predefined quality and security criteria. Access gates are crucial in enhancing the development processes control, quality assurance, and security. It's beneficial for everyone. Enhanced control. Access gate provides checkpoints in the pipeline, allowing control progression to differentiate. For example, code cannot go to staging directly unless it is deployed and tested on dev. And that means the dev lead should take care of all the merging and the pull requests, right? And once dev lead have checked everything, it is going okay. Then on staging, or maybe on the QA needs to make sure that everything is working fine, and then security will come into the play. And if you follow this process, that means before your code will go to production, all the teams have checked and verified, and nobody can check in the source code directly to production. Maybe one or two developers, which are senior, who are there with the company for a long time, can do that. But still, even whatever they check in, we will still verify, or even on production, that the code is properly checked. Like in the previous room, we studied the SAT and DAS tools, that the once you check in some code, it will always be scanned regardless of the branch. So if these kind of controls are there, we are good to go. Quality control. Gates ensure that code meets predefined quality standards before advancing. Security checks. Gates enable security assessments such as vulnerability scan before deployment. Yeah, so this is all pretty standard. We should be familiar by now. Implementation steps. Manual approvals require manual approval before moving to the next stage, ensuring through thorough reviews. So manual reviews means somebody needs to approve, maybe some business owner or some technical owner or somebody who is basically owning the solution that you're trying to deploy. So there should be always a manual approval button. Somebody needs to click on it in order to do that. Okay. So because this should not be automated, and that means even though there is a compromise and somebody have triggered your pipeline, you should know that why the pipeline is triggered. Once you will investigate, you will get to know that somebody have compromised your pipeline itself. So manual approval is a really good idea. Automated tests, set up automated testing, gates for quality check, unit test, integration test, etc. Security scan, integrate security scanning tool to detect vulnerability in the code base. We already covered this one before. Release gate, use gates to verify proper documentation, versioning, and compliance. This could be, for example, if some team needs to deploy something on production, they can, for example, send some emails to take approval. Once it is approved, and they document everything, that which kind of checks, chain sets, or check-ins or commits are going to production. You will have a proper documentation and versioning, and also your automated testing tools, either it is functional test or the security test, will get to tell you that if the compliance is okay and everything is working fine. So this is release gates. Environment validation. Validated target environment's readiness before deployment. Sure that, for example, if staging is not working before and you need to deploy something now, right? So you need to make sure that the VMs or the containers can be created or are okay to be created within your pipeline. Okay, it is to make sure that every dependency that is there within the pipeline or is required by your software once you are trying to deploy is there and it's working and it is live, right? So this is where the environment validation comes into the place. Rollback plan, include a gate for a well-defined rollback plan in case of issue post-deployment. This is very true. Now everything is moving to code first, so you should have a rollback plan, especially on the database side. Monitoring. Implement monitoring gates to assess post-deployment performance. So it really depends. The post-deployment performance could be defined as, for example, how the solution is performing under load, and what was the response time before, and what is the response time afterwards. So if you are using any monitoring tool, there will be a base timeline, right? So the base timeline will tell you this is the normal response time. And if after one deployment, the response time of your solution is increased, that there is some problem with your solution, and you need to investigate, right? And monitoring comes by default for if you're using containerized system. They have inbuilt monitoring, and they have also other tools that you can just plug in and get to know what is going on within your cluster. Parallel gates run gates in parallel to expedite the pipeline without compromising quality. Yeah, this is, I mean, subjective. Sometimes if the automated test is failed, you don't want to go with the security scanning, but I would recommend to go with parallel in case of automated test and security scanning. So even if one of them fails, you would usually say, okay, for example, on the step 4, you will say, if one of them is failed, then I'm not moving forward. I will just make this deployment as failed. Auditing is very important. Regularly review gate configurations and results to ensure effectiveness. This is very important because if you are trying to adopt agile kind of thing, that means you will always uh, take the lesson learned into the next sprint. Sure, it's kind of the auditing that you need to do. Auditing will improve your overall system solution, and the auditing will also help you understand if there is any risk, if there is anything out of compliance. The auditing will come into play to save you. Okay, the 2% concept. Okay, let's see. Even if we have access gates, we need to ensure that no single user can pass these access gates. That is very true. If you are a developer who initiate the build, you should be prevented from passing the next stage gate. So for example, if you check in something, okay, that means you cannot approve your own pull request, right? Or change request or comment to the next branch. Somebody needs to check in first, and then, for example, you are a team lead, then okay, it could be allowed, but there should be some other team lead where within your team hierarchy or your manager who needs to approve your check-ins. Okay, so this is where two team member concept will come into play. 2%. It should always be someone else. By enforcing this with the technical control, it can be ensured that in the event that a developer is compromised, a build cannot be passed through. This is referred to as the 2% rule. Even this could be bypassed if you apply the right amount of social engineering. Some build server may not allow you to ensure a control on the access gate to ensure that it is a different person. A good workaround in these cases is simply increase the count of approval needs from 1 to 2. Yeah. I would suggest even making it 3. That's somebody needs to take responsibility, and you should include all the stakeholders there so they know that what is going on, what we are deploying. If they have any concern, they will right away let you know that we cannot deploy this, or this is not the right time. This way, the developer provides one approval, but a secondary person has to provide the other approval. This is very true and very effective gate. Exploiting misconfigured access gates. Let's take a look at an example where access gates have been compromised. In this example, we will provide you with the access as Anna user. So Anna's user is compromised already. You will use this user for all exercises going forward. You can use the following details to authenticate get lab as Anna. So Anna tracker. Let me write it down. Anna tacker, and password is simple password. All right, let's move forward. Ash has provided Anna with developer access to his approval test repo, which can be found here. Okay, let's try this one here and see if it is accessible. Yeah, it is accessible. We are good. To protect the main branch of the repo, Ash has configured the main branch to be protected branch, where developers are only allowed to make merge requests, no direct code changes. Let's test this by updating the README file and try to commit the changes to the main branches. Navigate to the README file and click Edit. Okay. But before that, let's try Anna's user. Will it work? Or do we need to create the... Yeah, it is working. Okay. So this is the README file they are trying to say. We need to edit it. Okay. Click edit. We did the edit. As you can see, the GitLab is automatically requesting that we start a merge request with the changes we made. We haven't made any changes. Let me put a couple of enter here and then commit changes. Oh, it is saying start a new merge request. Did we already start a new merge request, guys? To quit changes. Okay. Immediately you will see that we have to make a merge request for our change, add a description and create the merge request. This is test description. Okay, should we do that? As thought the process behind this was that it would protect the main branch, as the company has a policy that states merge request must be approved by a manager. Since we are now forced to make a merge request, the main branch is protected. However, Ash has made the following two errors in the security thought process. Policies that are not enforced through a technology will not be respected by attackers. Sure, the policy says that a manager must approve the merge request, but if you read the merge request, you will see that from a technical standpoint, GitLab indicates the approval is optional. Uh, Let me see here. They say approval is optional. Yeah, it is optional. Approval is optional. Yeah, it is true. Although the main branch is protected by not allowing any direct pushes, since developer can still make merge requests, they can simply push their own merge request to commit code to the main branch. The 2% principle was not implemented to ensure that another person has to accept the merge request. Yeah, this is also very true here. And we have checked already, as you can see here. Failed to deploy production. Pipeline is failed. I don't know why, but yeah, this is true. Leveraging this mistake, and as an attacker, you can simply approve your own merge request. So it isn't even needed. You can then merge it to the main branch as shown below. Yeah, it is already merged at least, but the pipeline is failing. Why it is failed? Production. What happened? Job failed. Exit code is 1. UFRD and file. I don't know what happened here, but the job is failed basically. And this is our merge request, which is this one. And I don't even need to do anything here. Ready to merge, delete the source branch. Let me see if we need to go along with Set to auto merge. Wait. Merge unverified changes. Yeah, we'll merge it. Let's see what happens here. Yeah, okay. So I'm able to merge my own changes, um, which is not a good practice. And that means if I am a compromised user, I can merge anything here because there is no 2% uh, approval kind of setting in place. Okay, let's move forward. Reviewing the code in the main branch, you have made changes to the main branch. Now comes the fun part. The GitLab runner was configured to only run on the main branch. Since you can now push code to main branch, we can compromise the runner. Now that you know how to get your code to the main branch, make some changes to the GitLab CI.yaml file to get code execution on the runner. You can use any of the technique you have been taught up to this point. Okay. So we need to compromise our runner. Let's see if they will guide us through how we can do that. Otherwise we're gonna move forward. So we have few things that we can do. As you know, we documented a lot of the steps here. Either we can do one thing that we had used for shell.sh. We have the code here. For this, what we need to do is we need to execute this code somehow on the runner, and then we also need to have a web server. If we need to, we don't need to have a web server. We just need to have, I think, NC listening on 8081. And this was the code that we had used to compromise the pipeline. Okay. We no longer need to do that because this was the J agent, Jenkins in the Jenkins. So I think these two, the 51 line and 56 line, will do our bidding. Okay. So let's see how we can do that. Let's continue with our theory, and then at the end we will do the actual thing. What do you say, guys? Okay, protecting the pipelines. Protecting your GitLab CI/CD pipeline is essential to ensure the security of your code and infrastructure. Here are the steps you can take to protect your pipeline with access gate and prevent unauthorized code execution, like the example above. Okay, we'll not do that. We will first compromise, and then maybe we'll be able to do that. Limit branch access. Restrict the who can push to main branch. Only trusted developers should have the ability to push code to the main to this branch. You can do this by configuring the branch protection rules in your GitLab repository setting. Go to the navigate setting repository default branch. Configure the rules to require reviews before allowing changes. So this is fully protected. Let's see. So this was settings and repository. This is we don't have anything here. Just a moment. Okay, they are just telling us what we need to do. Maybe we'll not be able to do this step unless we have our own project, right? Review merge requests. Ensure merge request or pull requests to make main branch changes. Merge requests provide a way to review and approve code changes before merging. You can configure a merge request approval to ensure multiple team member review and approve changes. Yeah, this was the 2% approval cycle or 2% gate that we studied before. Use CICD variables. Avoid storing sensitive information directly in your GitLab-ci.yaml file. Instead, use GitLab CICD variables to store. Yeah, so use environment variables to. They should say that environment variables. I think they are not consistent with the terminology that they are using in these rooms. Store secret light API key, password, and tokens. These variables can be protected and restricted to specific branches and tags. Limit runner access. Only allow trusted runner to execute CI/CD jobs by specifying tags. You can register runners with specific tags and then restrict which runner can be used for job in your GitLab CI.yml file. Only runners with the appropriate tags can run jobs on the main branch. So, for example, you can put that, okay, the production or the main branch can be run on runner, for example, 03. Development will always run on runner 01. Staging can be run on runner 02, right? So this way you are segregating the environment, and if one runner is compromised, it does not compromise the runner 2, okay? Access control and permissions. Review and configure project level and group level access controls and permission. It is always good to review and ensure you have the least privilege by checking the project setting and modifying CI/CD configuration if necessary. Yes, regular audits. We already covered this one. Conduct regular security audits of your GitLab configuration and CI/CD pipeline. Review who has access and permissions and ensure that best practices are followed. Monitor and alert. Set up monitoring and alerting for your pipeline. Implement security monitoring solutions to detect unusual or unauthorized activities in your GitLab environment and CI/CD pipeline. Okay, so I already answered one of the question. What can we add so that merges are raised for review instead of pushing the changes to the code directly? Merge request. What should we do? What should we do so that only trusted runner executes CI/CD jobs? We can use, I think, we can specify tags, or maybe this is the answer. Limit runner access. And then is authenticated mother and follow the process to claim flag 3. So what we needed to do is to compromise the runners, right? So in order to do that, let's see what we can do. I will just simply make it as close merge request. Okay, so it is done. I'll go to the code again, repository, and we are already in the main branch. As you can see, we have any other? Yeah, we have other branches as well, but we'll work on the main branch. So this is the file that we try to exploit. Okay, so we have stage deploy, production stage deploy, then we have script. Oh yes, okay. So there is a task where we can execute a script. As you can see, they are already doing something. Echo starting translate engine and then Python 3 translate.py. That means the Python 3 is already there on the runner, so we can basically take advantage of this one, right? So let me edit it. So in order to do that, let's see, do we need to put this one here and then the script? Yeah, I think so. Okay, so I'll take my script here. So first of all, I need to know what is my IP address here. So I already told you how to get the IP address, right IP address. So we will do IP ADDR, and it will tell you we need to check the IP address with the CICD here. So our pipeline, our IP address is 1050.42.235. I'm checking for this one, CICD network, and this is our IP address. Okay, the IP address shown here in the attack box IP will not work. Okay, so you always get the IP address from the network itself, which is attached, and this is our IP address for CICD network. Okay, so we get that. Okay, next thing is to spin up NC LVP, and it should be 8081. All right, so we are listening on port 8081. We are good to go. So next thing is we'll take our script from here. Okay, I'll put it in the here in this step. All right. I hope this will work, but let's see. I'll put the IP address here, which is 10.50.42.235. Okay, we are good. We are good. And then I'll just commit the changes. It will start a new merge. I'll create the merge request here. Merge request is created. I don't need to approve. I think I just need to set auto merge. And it is automatically merging. I don't know if it will take time or something. Add it to the main branch. Can we do it automatically now, or 1 minute? Let's see what is happening here. I don't know if it is running or not, but let's see. Yeah, okay. So we already got the shell here. So first of all, we run ID. So this is GitLab runner, but what is the host name? Yeah, it is 201. 201. So that means it is grunner01. All right. We need to create some file here as well, right? So let's authenticate with the mother SSH. Mother at mother IP address should be 10.200.46.250. Yes. Password is mother knows best. I put it wrong, I think. Yeah, okay. Mother knows best. This time it should work. Okay, we will authenticate. Username is scientist Z, and password is, we already saved the password somewhere here. Okay, why it is doing like this? Here is my password. I will just copy it and paste here. Enter. So we are submitting, and this is the third compromise we are doing. Build pipeline compromise. Please provide the host name of the host you have compromised. Please use the name provided in your network diagram. So we know it is 201. So 201 is grunner, I think grunner01. Okay. So it is grunner01. Enter. In order to verify, okay, so we need to, okay, so what we will do, we'll do the same step that we are doing in our other task. Very simple. That what we need to do is scientist Z, right? So okay, so we will execute echo, and then the empty, paste here. Then it will go into a file in a folder called flag, and then the file is scientistz.txt. Let's see if this file is there. Cat flag scientistz.txt. Yeah, it is there. Now we can verify here. I'll put Y here, enter, and yeah, we got the flag. Finally, we got the flag. Copy the flag and put it in the room here. And we are good to go. Thank you guys for joining me on this journey, and we have completed task 8. In the next video we'll do the task 9, and video after that we'll do task 10 as well, and then on to the conclusion. It is a long journey, I know. We are taking our time to understand all the things, all the theory, and also the practical we are doing. It's really awesome experience here. So guys, if you like the video, please subscribe, put your comments in the comments below, and also you can like the video itself, give it a big thumbs up and share it with other guys, and try to subscribe and share with others, because we are targeting 1,000 users by August 2024. So help us achieve this goal, and I will see you in the next video, and see you. Bye.